Hey everybody, welcome back to my Puppet Edge series. We are going to be talking about the new EdgeOps module in this video. Let's learn about how we can automate network devices over NetConf. When it comes to network device management, for a long time, there have been limitations with things like CLIs or SNMP. So way back in the day, folks started bringing about the idea of NetConf as a protocol that people could use along with these Yang models to have a better interoperability. And over the years, we've seen vendors like Cisco and Arista, Huawei, Juniper, they're all bringing out their support for NetConf and allowing this to be enabled on their devices. This makes it a lot easier from a DevOps perspective to start automating and being able to use this for like a transactional approach to network device management. So of course, when Puppet team started looking at how can we bring about better network device management, going with an approach that could have used NetConf and these Yang models made a lot of sense. So what we're going to do today is I'm going to take you through a little bit about how it works and also how the EdgeOps module can then be used to run these types of tasks. Let's dive into how the EdgeOps module kind of functions. The EdgeOps module is a premium module available on the Forge that is part of the Puppet Edge package. It uses NetConf and Yang to accomplish the goal of automating network devices. So we can look at the Yang models as like the definition. That is what possible values are accepted, what calls are able to be made to this device. It defines what the device can do. And then NetConf is used as your transport. This is how you are going to actually do the talking in a secure way to your network device. And then we have the EdgeOps module itself, which is capable of executing tasks that are coded up with your automation using the Yang models and then talk over NetConf to be able to communicate with the device itself. So with those three pieces together, you have the ability to do your automation. So let's talk about what that flow looks like when you want to use the EdgeOps module. First up, we are going to be going and making sure that the network device is part of the inventory because this is where it all starts, is having that centralized inventory. Once that piece is in the inventory, now we need to actually go and build a task that's going to do some automation. So this is going to involve a Ruby file, that's the code that's going to run, and also a JSON file that defines what the task is. We deploy that up so that it's ready to run. Now we're going to execute the EdgeOps task. When we run the task, it's now going to go through, take the code and the definition of what we have, communicate with the device, and send that new configuration of the changes we want over to the remote network device. Ultimately, when we use that EdgeOps module, it's also going to get a result. And that result can then be stored back into our central Puppet Enterprise store, and we're able to see the results of what happened with those EdgeOps tasks. Why don't we take a look at some example of what those EdgeOps tasks look like? We're going to look at three. One's going to be about creating a user, second one about managing NTP servers, and finally, being able to assign a VLAN to a network device. So we're going to take a look at what the Ruby and JSON files look like and how they're a little bit different for different scenarios. Alrighty, so I'm going to open up the JSON file here for a Puppet EdgeOps task that does a user creation. You'll see that it's got some very basic outline of what the task looks like. What are the input parameters? For example, in here, we want to pass a username and a password for the user that we want to create. There's also some references to specific files that are in the EdgeOps module. This helps the EdgeOps module know what it has to use to be able to communicate and the task for it to run. All right, so why don't we go take a look at the Ruby code that goes along with this task. This is what's actually going to be executed by the EdgeOps module against the device. Other than referencing EdgeOps stuff, the big thing to look at here, probably the pieces we want to learn about, is how we start off first with extracting data from the session. So we need to be able to open up the parameters, extract that username, that password. What do we want to do with in here? Then you'll notice that we take this in and start doing some input validation, but most importantly, building up this XML block. This is the Yang config that we are going to send across the wire of the change we want to make. Then we're going to use the session.edit config to be able to send this new configuration across the wire, apply it into the device, do a commit, and then report the results back. Why don't we take a look at another example on how that's different? In this scenario, I'm looking at managing an NTP server. I want to be able to go in through all of my network devices, and I want to make sure they're all using the same set of NTP servers and especially the same default so that everybody is timed in on the same system time. In this case, we again have a JSON file. We are doing the description of what the parameters are. It's very similar. You'll notice that we have the ability to do arrays as well. So one of the differences in this one is that we have a parameter that is an array string for the servers so that we can have a list of servers. Now let's look at what the Ruby code is and how this one's different. In this case, we're still extracting the parameters like we did, but obviously different attributes, we're reading them differently. The open config is built up in here with the list of the servers provided. So we're taking that list, we're building up the config with all of that, and then adding them in to one bigger XML config that then gets sent across the wire in the same edit config, commit, and then reporting on the result. So just like in scenario one, this is running a very similar type of flow, right? Extract parameters, build up a config, send that config over the wire, commit it, and then report on the results. Let's take a look at a scenario of configuring a VLAN. In this case, we're going to have a JSON file that's very similar. It's a lot of the same things we're seeing where we're defining the parameters that go in. I'll call out something that's in here where we have an optional parameter. This was seen in one of the other ones as well, where we can have parameters that are defined that may or may not be there. We have to handle that in the code as well. But this is really defining the structure of the task. Now let's take a look at that task code. When we look at this scenario for the VLAN, we see the same pulling input parameters out and then trying to do some validation, but we're building the configuration a little bit differently. You'll notice that first, it's building the basic VLAN configuration of how we want to do the open config, but then it's got a separate config for those optional routing IPs. In the other ones, we were building up one config that was being sent over the wire, committing that change and bringing it back. But after building up these two configs, you'll now notice we're doing two edit config calls. One of them always happening, changing the VLAN configuration, and the other one only happening if we've actually provided some kind of IP list in that optional parameter. So you can see how we can do a session edit, then another session edit optionally, and then finally do a commit once we've done all these transactions. This is really powerful to allow us to build up code that is really logical in how it decides on how it wants to apply it and in what order we want to apply things. Ultimately, it's very similar to the other styles. When we get to the end, putting the result out, making that commit, the whole concept is very much the same. Define the parameters we want to provide, read the parameters that have been provided, and then go execute a config change, commit, and report the results. Now, all of these examples are available on GitHub, but how did I build these out? I am not an expert in doing Puppet tasks, so I use some help. And one of the things that came along with Puppet Edge is a code assist tool, which I'm going to look into in another video so we can see how you can use Puppet Code Assist to talk to our devices, get the information we need, and then build these with very simple commands. I hope that was helpful learning just a little bit about how the Puppet EdgeOps module works. We're going to dig into some other parts of Puppet Edge in some upcoming videos, so make sure you subscribe to the channel, and we'll see you soon. Cheers.